Hi everybody. I wanted to post a video today about how to interpret quantitative data. With many of you starting your Wikipedia assignments, I've been getting more and more emails. That's good. I thought that it would be good to show you all how to look at quantitative data, look at statistical data for in these articles, and really in articles you read going forward. One of the issues we run into in upper division poli-sci classes is that many of you don't have sort of the research methods class or similar training. So it limits the articles we can assign. So one of the things I wanted to add to this class and really start to get you all exposed to is the idea of how to read tables, how to read statistical tables. As a side note, this will be on your exam. I'll post a few questions about you labeling different parts of the table. So you should be aware, make sure you can do this. Normally I would go through in class and have you all call on people and say, okay, what does this mean? What does this mean? What does this mean? But for this class, since we can't do that, I'm going to put a few questions on the exam because I really think it's important that you all can do this, both for the articles you're going to read for the Wikipedia assignment and for the next paper, and just for the rest of your poli-sci classes. So hopefully our goal will be so we can assign more readings as opposed to having to pick readings that don't use as much quantitative analysis. So a few things I want to talk about. The first is the idea that what we're doing is called hypothesis testing. It's basically what you remember from the scientific method back in 5th grade or whenever you took those classes. One of the things you're going to do here is, in political science at least, what makes it a science versus, let's say, history, which is in the humanities, is we test hypotheses. We attempt to answer questions using evidence, and we're basically, I said, testing hypotheses, trying to figure out how the world works, specifically how the political world works. We do that, one way of doing that at least, is through what we call the broad class of category here is called regression, quantitative regression, statistical regression, I guess. There's different flavors and then there's different styles, but one of the things, basically the overall category is called regression analysis. So you have a dependent variable, and as you might remember from your 5th grade science class or whatever, your dependent variable is the one you're trying to predict. It's the ones we're trying to figure out the effect of different variables on something. When does this happen? When does X happen? Well, X is your dependent variable. It's a variable you're trying to predict a change in. So just to be clear, the dependent variable is the variable you're trying to predict a change in. And its values depend on your independent variables. Those are the variables that cause the change in X. I shouldn't use the word cause, but effectively they're variables that the framework we're going to use is basically going to be causal. There's a lot more science to that, and it's well beyond the scope of intro class, let alone even like a research methods class here. But we're going to describe it as causal. If you go on to take more research methods class going forward, you'll learn the difference between correlation and causation and those sorts of things. So the dependent variable is caused. Changes in the dependent variable are caused by changes in the independent variables. Those independent variables are things that predict changes in your dependent variable. So hopefully that's clear. I'm showing a paper here. I'm not sure how much of this you can read because I know YouTube is kind of sketchy and Camtasia is kind of sketchy. But this paper here is a paper that a former undergraduate of mine wrote back in days of yore, I think 2010. This won the National Pi Sigma Alpha essay competition. And the paper basically looks at when do members of the House of Representatives switch their position on a veto vote. So as we've talked about in the Congress lecture, you have a normal vote and then you have the override vote, or the initial passage vote and the override vote. When do members of Congress vote, let's say, yes on the initial passage vote and no on the override? When do they switch their votes? Because that's going to show a change in behavior. So our argument in this paper is that presidential speeches cause members of Congress to change their opinion. If the president speaks, more members of Congress are likely to switch their vote to the president's side. So if you look at Table 2 right here, I'm trying to highlight that. There we go. Table 2 right here. We have a couple different things in this column. We have on the left column here, we have our list of independent variables. What I've highlighted here, that includes the speech before the original vote, if did the president give a speech before the veto override, what was the president's approval, what was the margin of the original vote, and what proportion of members of Congress were in the president's party. Those are our independent variables. They explain whether a member of Congress switched to the president's position or not. Hopefully everybody's clear on that one so far. The left side has all your variables. Down here where it says constant, that is, you don't need to know too much about that, but that's the intercept. Basically in your slope-intercept form of a line, y equals mx plus b from in algebra. That was in algebra 1 back in the day. I still remember my teacher was obsessed with y equals mx plus b. But you know, the slope-intercept, these are the slopes right here. This is the intercept. The constant is just the intercept. You can typically ignore that, at least for the purposes of what we're doing here. You shouldn't when you get it more advanced, but for now, just ignore that. Also, down here it says n. That's the number of cases we have. So how many, basically, bills did we have that had both a veto and an override vote? And there was 57 in our data set. But we're really interested in these 4 or 5 variables right here. The left column, again, is the variable itself, and those should be defined somewhere in the paper. The right column are what we call the coefficients and the standard errors. The top number here is the coefficient, and that basically is the effect that your independent variable right here has on your dependent variable. So a speech before the original vote has a negative 0.096 effect on switching. Similarly, a speech before the veto override has a 0.065 effect. Presidential approval has a 0.002 effect. Margin 0.330. Proportion of the member of Congress's of the president's party, positive 0.112. So okay, these are this top number here is the coefficient. The bottom number is the standard error. And think of that, the basic definition is going to be, think of that as the amount of uncertainty we have. It's almost like the margin of error in a political poll. How much uncertainty do we have around this top number right here? So the top number here is 0.096, but we have 0.092 uncertainty around that. What you're going to be looking for are a couple of things here. Again, if you take the research methods class with me, we go into this in great detail. We really explain all the math behind it, what exactly it means, how it works. But for this, I just wanted to give a hopefully under 15-minute talk so you could at least read statistical tables and interpret them with the basic competency. So what we're looking for basically is a number on top here that is twice as big as the number on the bottom, the number in parentheses. The coefficient should be twice as big as the standard error. And when I say twice as big, I mean the absolute value. So when this is negative, don't worry about that yet. One thing they'll do typically is they will put a star or some sort of symbol next to it if it's twice as big. It doesn't always happen, but that's the basic idea. So you're looking for a star here. What that means is the variable is what we call statistically significant. What that means is we are at least 95% confident that this variable correlates with the value of our dependent variable, that a change in x here correlates with a change in y, our dependent variable. If there is no star, if the number isn't twice as big as the coefficient isn't twice as big as the standard error, then it doesn't matter. It means it's not statistically significant and there's no effect that we can prove. So looking down here, the proportion of members of Congress who are in the president's party, that's 0.112. The standard error is 0.243. That's not even half. Therefore, this is not statistically significant. Therefore, the proportion of members of Congress to the president's party does not affect the proportion of switchers to the president's position. If it's not twice as much, then it's not significant. Therefore, it doesn't affect it. Everybody with me so far? Hopefully. Now, let's look at a different one. Let's look at the margin of the original vote. Right here, we see the margin of the original vote was 0.330, and the standard error is only 0.118. So that's more than twice as much. It's almost 3 times as high. That means this is statistically significant. That means the margin of the original vote predicts the proportion of switchers to the president's position. So step number 1 is look for a coefficient twice the size of the standard error. Look for stars. Got it. Now, the next thing we do, and this is the last thing we do, this is really simple. Do not overcomplicate it. The next thing we're going to do is we're going to look, is this number positive or negative? If it's positive, what that means is it has what we call a positive correlation. The higher the margin of the original vote, the higher the number of switchers to the president's position. When X goes up, Y also goes up. They go in the same direction. I'm making a hand gesture here you can't see, but it shows they're going in the same direction. If it's negative, so if this number was negative right here, just put a negative sign in. Uh-oh, it's negative now. That means it has a negative correlation. What that means is as X goes up, as the margin of the original vote goes up, the proportion of switchers to the president's position goes down. They go in opposite directions. So as the margin of the original vote goes up, the proportion of switchers goes down if that number is negative. This is all, I'm going to delete that. This is all you're going to do here. This is all you're going to look at. Do not look at the size of the coefficient. Do not look at anything else. Positive, stars. Or negative and stars. Do not look at the size of the coefficients. You don't know enough to interpret the sizes yet, the relative sizes. There's a lot that goes into that. Don't bother interpreting that. All you want to do is go positive and stars or negative and stars. One more note on this. You'll sometimes see like a cross, or in this case a plus right there in the speech before the veto override. This means that we can call it statistically significant but with not as much certainty as a star. Or when it's twice as much. Again, this top number is much higher than this bottom number. Therefore, we can be very confident in that this is a statistically significant effect. This is higher, but not as high. It lets us say with 90% certainty, basically, less certainty, but still certainty, that this is statistically significant. So let's look at it. It's significant at 90%. That's good. There's a cross there or a plus. We're happy. It's a positive number. So that means if the president gives a speech before the veto override vote, the proportion of the switchers to the president position does what? It goes up, right? Because this is a positive number here. If the president gives a speech before the veto override, the proportion of switchers to the president's position goes up. Again, you're looking for either stars, crosses, some sort of symbol, or you're looking for a coefficient right here that is twice the size of the standard error. That's step number 1. If you get that, it's statistically significant. Then you just look at positive or negative. If it's positive, there's a positive correlation. As X goes up, Y goes up. Or as X goes down, Y goes down. They go in the same direction. If it's negative, that means they go in the opposite direction. It's a negative correlation. As X goes up, Y goes down. Or as X goes down, Y goes up. That's all you're going to do here. That's all there is to it. I know people see numbers and they get scared because we have this idea that, well, I'm allowed to be bad at math. No, you're not. And the other thing is, this isn't math. These are numbers. You're not doing any calculations here. You're not doing anything other than looking at a number, seeing if this is twice as big as this one, and if it's positive or negative. Final thought, because I have about a minute left here before the 15-minute limit, is the tables might not always look exactly like this. The number might be the side. It might not be in parentheses, whatever it is. But you're looking for the coefficient and then the standard error. Do that. Interpret the numbers in your articles you read. You will be smarter. You'll be better at political science. You'll be better at evaluating evidence. You'll do all those things we want you to do. One of the goals in this class is for you all to be able to interpret quantitative evidence, at least have an intro to that. And so that's what this lecture is about, and that's why I'm going to put a few questions on the exam. Thank you all very much for watching this bonus video, and I'm looking forward to the rest of the videos.